A radical is an atom, molecule, or ion that has an unpaired valence electron, 1, 2, with some exceptions. These unpaired electrons make radicals highly chemically reactive. Many radicals spontaneously dimerize. Most organic radicals have short lifetimes. A notable example of a radical is the hydroxyl radical, HO, a molecule that has one unpaired electron on the oxygen atom. Two other examples are triplet oxygen and triplet carbene CH, two which have two unpaired electrons. Radicals may be generated in a number of ways, but typical methods involve redox reactions, ionizing radiation, heat, electrical discharges, and electrolysis are known to produce radicals. Radicals are intermediates in many chemical reactions, more so than is apparent from the balanced equations. Radicals are important in combustion, atmospheric chemistry, polymerization, plasma chemistry, biochemistry, and many other chemical processes. A large fraction of natural products is generated by radical-generating enzymes. In living organisms, the radicals superoxide and nitric oxide and their reaction products regulate many processes, such as control of vascular tone and thus blood pressure. They also play a key role in the intermediary metabolism of various biological compounds. Such radicals can even be messengers in a process dubbed redox signaling. A radical may be trapped within a solvent cage or be otherwise bound.
Today to make it absolutely clear. The United States is committed and will remain committed to achieving an AIDS-free generation. We will not back off. We will not back down. We will fight for the resources necessary to achieve this historic milestone. How difficult it can be to talk about a disease that is transmitted the way that AIDS is. But if we're going to beat AIDS, we can't afford to avoid sensitive conversations, and we can't fail to reach the people who are at the highest risk.
Begin with a question for Mr. Gates. Your foundation has made investing in it.
The ultimate tool will be a vaccine, and scientists are making great progress. They understand the shape of the virus, how to generate antibodies.
AIDS is caused by the human immunodeficiency virus, HIV. This is an enveloped virus. The envelope is derived from the host cell membrane with viral glycoproteins such as GP120 and GP41 inserted into the membrane as the virus leaves the cell. The core is composed of P24 capsid protein, and the P17 matrix protein helps maintain viral structure. Inside the core are 2 identical copies of single-stranded RNA viral genome and 3 enzymes, reverse transcriptase, RT, protease, PR, and integrase, IN. To establish infection, HIV must first attach to its host cell. Attachment occurs by interaction between GP120 on the surface of the virus and the CD4 antigen receptor on the surface of the host cell. In addition to the CD4 receptor, there must also be a co-receptor on the host cell. The co-receptor differs for different host cell types. In T lymphocytes, the co-receptor is called CXCR4, whereas on macrophages, the co-receptor is called CCR5. After attachment, the viral envelope and host cell membrane fuse, resulting in entry of the virus into the cell. Once the RNA is released into the cytoplasm of the host cell, reverse transcriptase makes a DNA copy of the viral RNA genome. As the DNA is being formed, reverse transcriptase degrades the RNA strand. A complementary DNA strand is then added by the reverse transcriptase, and the ends of the resulting double-stranded DNA segment are joined non-covalently. Treatment with nucleoside analogs or reverse transcriptase inhibitors interferes with these steps. The resulting circular DNA is then moved to the nucleus and inserted into the host cell chromosome by the viral integrase, IN, enzyme. The integrated viral DNA is now referred to as proviral DNA. Following integration, the proviral DNA may remain dormant, or with host cell activation, RNA may be synthesized from the DNA, yielding messenger RNA and viral genome RNA. Viral messenger RNA is translated, yielding viral enzymes and structural proteins. Some of the functional proteins are formed by cleavage of a long polyprotein by the enzyme protease. Protease inhibitors interfere with this step. GP41 and GP120 are inserted into the host cell membrane, and the structural proteins surround the viral RNA to form the core. Finally, the virion is released by budding.
It's clear that even if you take the most efficient way of doing this work, that the number of people who will eventually need to be on treatment, that the amount of money we have is not enough to treat those people. And so the world will make a decision how much those lives matter.
What is your response to critics of the Global Fund when they say the fund is not managing their funds appropriately?
The AIDS disease is caused by a virus, but the AIDS epidemic is not. The AIDS epidemic is fueled by stigma, by hate, by misinformation, by ignorance, by indifference.
I had sent word ahead that I wanted to know where the names of friends.
Yes, I hope and pray that we will all discover a vaccine. We all do. But we won't get that vaccine to those in need if governments shun their most marginalized citizens. That is why compassion is critical. That is why love is the cure. Cynical people will say, well, how can a sentence...
A familiar radical reaction is combustion. The oxygen molecule is a stable diradical, best represented by OO. Because spins of the electrons are parallel, this molecule is stable, while the ground state of oxygen is this unreactive spin unpaired triplet, diradical. An extremely reactive spin paired, singlet, state is available. For combustion to occur, the energy barrier between these must be overcome. This barrier can be overcome by heat, requiring high temperatures. The triplet-singlet transition is also forbidden. This presents an additional barrier to the reaction. It also means molecular oxygen is relatively unreactive at room temperature except in the presence of a catalytic heavy atom such as iron or copper. Combustion consists of various radical chain reactions that the singlet radical can initiate. The flammability of a given material strongly depends on the concentration of radicals that must be obtained before initiation, and propagation reactions dominate, leading to combustion of the material. Once the combustible material has been consumed, termination reactions again dominate and the flame dies out. As indicated, promotion of propagation or termination reactions alters flammability. For example, because lead itself deactivates radicals in the gasoline-air mixture, tetraethyl lead was once commonly added to gasoline. This prevents the combustion from initiating in an uncontrolled manner or in unburnt residues, engine knocking or premature ignition. Preignition. When a hydrocarbon is burned, a large number of different oxygen radicals are involved. Initially, hydroperoxyl radical, HU, are formed. These then react further to give organic hydroperoxides that break up into hydroxyl radicals, HO. Polymerization. Many polymerization reactions are initiated by radicals. Polymerization involves an initial radical adding to non-radical, usually an alkene, to give new radicals. This process is the basis of the radical chain reaction. The art of polymerization entails the method by which the initiating radical is introduced. Newer radical polymerization methods are known as living radical polymerization. Variants include reversible addition fragmentation chain transfer RAFT, and atom transfer radical polymerization, ATRP. Radical intermediates in the formation of polymethacrylate, plexiglass or perspex. Being a prevalent radical, O2 reacts with many organic compounds to generate radicals together with the hydroperoxide radical. Drying oils and alkyd paints harden due to radical cross-linking initiated by oxygen.